Hi, you've clicked on to today's tropical tidbit for Sunday, March 17th, 2013. And well, it's about that time of year again to start talking about the upcoming hurricane season, and we'll start off as usual with the global sea surface temperature anomaly profile, which we can usually get a lot of information from at this time of year. And straight off in the Pacific, we notice that there doesn't seem to be much difference from last year. We still have a neutral ENSO signal with neither colder nor warmer than normal water in the Nino regions, and it's somewhat uncertain where this will go during the hurricane season, whether it will warm up a little bit, go down a little bit, or stay just flat neutral. But what we do see is that we still have this negative PDO with a horseshoe-shaped ring of cooler than normal anomalies off the western coast of North America with warm water east of Japan, and this negative PDO continues. And usually when these things are well defined out here, it's pretty hard to get an El Nino roaring in the Pacific. So I imagine that even if this warms up a little bit, it'll be a warm bias neutral at most, and I don't think we're going to see a full-blown El Nino this summer. But we'll talk about the forecast for that in a little bit more. But we can see last year the comparison again, fairly neutral down here, cold PDO, so not much different in the Pacific from this year, or from last year rather. However, the Atlantic is a different story. This is actually a lot different this year. Last year what we had is cold water in the tropics with warm water displaced into the mid-latitude Atlantic. This year we have exactly the opposite, with a lot of warm water now building in the tropical Atlantic, with cooler water to the north and warm water to the north over the Arctic. And this is the positive Atlantic tripole pattern that I've talked about before, where if it develops during the winter, the late winter and into the spring, it can end up persisting into the summer, and this can end up affecting the Atlantic tropical activity. Right now, these anomalies don't actually do a whole lot. They're more of a result of a pattern rather than a cause of a pattern. What has caused them right now is a pressure pattern that has developed only recently. This is from February through mid-March, and this has a lot of blocking developed over the Arctic and lower than normal pressures where the Azores high is supposed to be. This is a negative NAO pattern, North Atlantic Oscillation. This reduces the strength of the easterly trade winds over the tropical Atlantic waters. Less wind speed means less evaporative cooling. It means the spring sunlight can warm the waters more than usual. And then the low pressure up here brings down cold air and lots of wind that cools the water in the mid-latitudes, and therefore we develop this tripole pattern with an active storm track where the cool water is and warmth in the tropics. Now these anomalies have been caused by this pattern but aren't actually doing much to the tropics right now. If we go out into the Atlantic, you can see it's barren, of course. There's not much of anything out here, no convection. That's because we have a big equatorial ridge sitting over the tropics at this time of year. So the water isn't really affecting the atmosphere too much right now. But when we get into the hurricane season and we start to get the intertropical convergence zone up here, this warm water will start enhancing thunderstorm activity. And what happens is you get rising motion where the warm water is, and then you get sinking motion where the cooler water is. And what happens is the sinking air helps enhance convergence to the south where the upward motion is, and it just feeds back on itself and enhances the convection. So this pattern is very favorable for an active hurricane season in the tropical Atlantic, and the season is in good company so far, because in similar years, similar patterns existed in 2005 in March, where we had warmth in the south, cool water to the north. Obviously, this was a huge year. We had the same kind of look in 2010, warm water, record warmth off Western Africa, and then a cool belt in the mid-latitudes. That was a big year. And 96 had warmth in the tropics, cool water to the north, and this was a pretty decent year in terms of ACE. It's in the top 15 ACE years with 13 named storms. So this year is in good company with some of these high activity seasons that started off with a sea surface temperature profile similar to what we have now in the late winter and early spring. And I believe that this will help focus upward motion in the Atlantic this year, and this will be a focus for activity as long as this does not blow up into an El Nino, which it doesn't seem likely to do at this point. Now, what we're going to do now is pick analog years that are similar to this year. What I decided to do this year is simply pick neutral ENSO hurricane seasons, since that's the most likely that this one will be, is around neutral. And I picked only neutral seasons which also had similar sea surface temperature profiles in late winter and early spring to this year. And what I came up with was only 4 years, 1952, 1966, 2005, and 96. And you note these are the sea surface temperatures in March and April, and you can see warm water in the tropics, cold water in the mid-latitudes, very similar to this year, positive Atlantic tripole positive AMO, and this is generally a favorable pattern. Now, here's the winter, or the beginning of winter, December and January temperatures for the analog package. And notice what we had. We had warmth over most of the United States, most of the cold air bottled up in Canada. But then if we go to February and March, it cooled down and we turned cold in the United States with all this blocking showing up near Greenland. Compare that to this year. December and January, it was warm in the United States, cold was bottled up in Canada, and now in the last 6 weeks, guess what? It's turned cold so far through mid-March. This is very similar to the analog package, as this blocking really developed and overwhelmed the negative PDO, which won the battle by keeping ridging over the southeast through the first half of the winter, but the second half of the winter, it flipped. And now we have cold air that is still ongoing in outbreaks over the eastern United States, very similar to the analog package, which also turned cold. So it's showing the same trend in the winter pattern, and when you get all this cold air coming down here, it cools the water off the southeast U.S. and helps warm the water in the tropics down here by reducing the trade winds. So all of this is working together. The winter pattern over North America does affect the hurricane season this far in advance, because the sea surface temperatures that are promoted by the winter pattern end up persisting usually into the summer and can affect what the tropics do. So there is a connection here that is showing up in the analogs, which is interesting. Now here's the ENSO forecast from the European, which is probably the best model we have. Most of the seasonal models I've seen are just about flatline all year. Near the neutral line. The European is a little bit warmer. The ensemble mean is about like this. It gets pretty warm, not into El Nino territory, but warm biased neutral by August and September. But you see some of these members also turn downward towards a weak or cool biased neutral by the peak of the hurricane season. So it's really uncertain. It's kind of awkward to have a neutral ENSO at this time of year, because in the spring the models do the worst at forecasting the ENSO, because this is a transition period for that pattern, and it usually can go either way when it's neutral at this time of year, or it could just stay neutral. It could be that it just stays neutral, but I think either way, what we're seeing now is a focusing of the heat in the tropics already showing up over the Atlantic. Regardless, this isn't that warm yet. We have a cold PDO. A lot of the tropical heat is already being focused here, which means that even if we get a warm biased neutral pattern out in the equatorial Pacific, the upward motion in the global tropics will tend to focus where the warmest water is relative to normal, and that for now is over here. And if the pattern persists, it will stay over here, and this will be where the upward motion consolidates and give the Atlantic an above normal season. Now here's the European forecast for the tercile distribution of mean sea level pressure, and what we see is a kind of a neutral thing going on here in the equatorial Pacific and the Atlantic region. What's interesting about this is that just a month ago for the same period we had a bunch of high pressure showing up over the Atlantic, and this was radiating of a below normal season forecasted by the European model, and looked more like its forecast for last year, which had a lot of high pressure in the tropics, and it ended up being right about no activity in the main development region, but a lot of activity did occur north of that in the mid latitudes. But you see what it showed last month, and this month a lot less high pressure, and it's more of a neutral look, and so the trend is down. And the European is usually pretty good at capturing this pattern, but it ended up not being so good capturing the winter pattern over the Atlantic and North America during the end of this winter, during the last 6 weeks. So it's interesting to see it showing a change in the tropics, which corresponds to the change in the winter pattern that has occurred. If this trend continues down, the European may be showing a more favorable pattern for the Atlantic overall as this year progresses. Chances are it won't actually be as bland and neutral-like as it's showing in here. It's probably in the process of evolving to something different, possibly more favorable for the Atlantic, which would support what we've been talking about. Now here's the UK Met, which also supports an above normal season. This is June, July, and August precipitation anomalies, wetter than normal across most of the main development region, and the Gulf of Mexico and Caribbean above normal precipitation, tongue of dry, indicating kind of a La Nina-ish pattern still off of South America. Interesting though, it has the intertropical convergence zone farther south over Africa, with dryness here, indicating it's trying to keep the African waves to the south, but then it looks like it tries to make the Caribbean more active as a result. So either way, it's showing a mostly active pattern in the Atlantic as we go into the summer. Here's the National Multi-Model Ensemble mean. This takes the average of several North American ensemble seasonal forecast models and averages them. And notice we have above normal precipitation in the main development region with drier than normal conditions near the equator. When you see these coupled bands of anomalies, this means that the intertropical convergence zone is farther north than normal and is more active than normal, providing a greater than normal intersection of convection with areas north of 10 latitude where the Coriolis effect can help spin up disturbances into cyclones. So this is indicating an above normal season with African waves being active, and it's interesting though, see this band of precipitation in the central Pacific that's above normal. This model is actually indicating an El Nino. The sea surface temperature map, which I do not show, shows 0.5 to 1.0 positive sea surface temperature anomalies in the equatorial Pacific on the ensemble mean, which is an El Nino pattern, but it's interesting it still has an active Atlantic, which I think ties into the fact that if we don't get a really strong El Nino out here, the pattern right now favors the Atlantic still being active regardless of what really happens in the Pacific. Even if we get a warm bias neutral or even a weak El Nino, I think the Atlantic will still be favored for a good bit of activity this year. Now here's our analog years. Sorry about that. Here's 1952, and what we've seen here is this is actually a fairly weak year in terms of numbers. There were only actually 6 storms recorded in this year, though of course that's assuming there was actually nothing else in this box, which is somewhat unlikely given it was the 1950s and we couldn't monitor everything out there. There were probably a few more storms than shown, but it's obviously obvious this wasn't a huge year in terms of numbers. But all of these except one were hurricanes, and 3 of them major. A good congregation of ACE tracks in the southwestern Atlantic. 1966 had 11 storms, a healthy year though. You can see a lot of storms coming out of the main development region and coming into the southwest Atlantic. That indicates a healthy season. And 1996, very similar, lots of tracks coming out of the deep tropics. Instead of developing way out here in the middle of nowhere, they're coming out of the tropics. This indicates a healthy year, and when you can get healthy years, as these analogs show, similar to this year, if you combine that with enough warm water and a global profile that promotes upward motion, that can really take off and turn into a higher active season. That happened in 2005, of course, when everything went to heck and we had the strongest season that we know of in known history. And storms were everywhere here, but most of the concentration was in the Caribbean and the Gulf of Mexico. And it's interesting to see 2005 and 1952 together in an analog package like this. But again, if we combine it with enough favorable conditions, there were reasons why 2005 blew up and 1952 did not. This year is not as big as 2005, which we may not have one as big as 2005 for many decades to come, but this will not be as big as that. It'll probably be bigger than 52 and 66. I think 1996 in this package is the closest to what we'll have this year, though I think we'll have a couple more storms than the 13 that developed here. This is probably the closest, I would say. A cross between 96 and 2005, weighted closer to 96, is what we'll have this year. So I think about 14 to 16 named storms this year. Last year we had 19. But a lot of them were weaklings, and a lot of them developed up here in the middle of nowhere and lasted for about 2 days before dissipating, never became hurricanes, and that has seemed to be a trend lately. We're getting a lot of wimpy storms getting named, so it's hard to say exactly how many named storms we'll have, but I think in terms of total accumulated cyclone energy, we will have more activity this year than we did last year because we're going to have a more active deep tropics with storms coming out and developing where they're supposed to develop, not up here where a lot of subtropical stuff happens and a lot of these storms develop and recurve right away and don't have a lot of time over water to develop and pump a lot of heat into the atmosphere. So in general, I think we have an above normal season coming, with probably 1996 being the most similar year in our analog package, with lots of activity in the tropics and the general track distribution that we'll have. Now, where these storms go is the bigger question. Of course, forecasting the overall level activity is all well and good, but we really care about where these storms go and whether they will affect lives and property in the Caribbean or the United States or anywhere else. And this is a little bit difficult to do during the winter, but one of the tools we can use are the analog years that we have picked, and if they were picked well, they can provide hints as to how things are going to be during the season in terms of track congregation. Now, if we start out 1952, notice there weren't that many tracks, but most of them were congregated in the southwest Atlantic. 1966, notice again, tracks coming out of the deep tropics focused in the southwest Atlantic, and then 96 has the same thing. It's actually interesting how similar these 3 years are, specifically with tracks coming out of the main development region and heading into the southwest Atlantic. This is probably a testament to the fact that we had a positive Atlantic tripole. Warm water focused here, cool water to the north, helped focus the storms into the main development region, and then the negative PDO pattern probably developed enough ridging up here that they could get pretty far west, and they end up recurving into the Carolinas here in 96, most of those hurricanes. And some landfalls can occur on the eastern seaboard in such a pattern. 2005, of course, blew up with storms everywhere, but you can see the main focus of power, namely major hurricane tracks in red and purple here, are down in the Caribbean and the Gulf of Mexico. So pretty far west, focusing of most of the tracks in these years, which again is a testament to the pattern that these seasons developed in. And of course, it would be nice to assume that the analog pattern is going to repeat itself, but often it doesn't. It doesn't always work, of course, and we've seen a couple of examples of that in the last few years where we've had a lot of recurvatures in years that seemed like they might have a pattern that favors landfalls more, and the ongoing drought in U.S. major landfalls continues. A lot of the storms have been going out to sea despite highly active years recently, so we need something else. The problem, though, is that when looking at the pattern in the late winter and spring, right now we're in mid-March, we're 6 months from the peak of the hurricane season when landfalls really start to occur in September. And if we look at the pattern between years that had many landfalls and those that didn't, there's really not that much of a difference. Here is, for example, the 500 millibar anomaly pattern during high ACE years. Actually, these are just years that have 3 or more hurricane landfalls on United States soil, regardless of ACE, but they usually have high ACE anyway. Notice, of course, we have the ridging over south of Hudson Bay over the Great Lakes. No surprise there, helps direct storms into the coastline. If we look at years that had fewer than 3 hurricane landfalls but had high ACE, we notice the trough over the eastern part of the United States, which is, again, no surprise. The trough helps direct storms out to sea, so fewer landfalls. The difference between these two patterns, if you look, is really not that different. There's very few differences we can draw on as a forecasting tool. The one thing you can probably pin down, which is what I've noticed, is that in years where there's recurvatures, this trough over the Aleutians due to the negative PDO is farther back over the Aleutians, whereas if we have high landfalls, this trough is farther to the east over the Gulf of Alaska and western Canada. And I think this has to do with the fact that if the PDO forces this trough far enough to the east, close to North America, it forces the jet to bulge northward over southeastern Canada and develop this ridge here, which blocks the storms and causes them to come into the United States. If the trough is too far west, then the jet doesn't get forced to bulge over the eastern United States, and it just tends to crash into a trough here, digging into the upward motion that's occurring in the tropics, because these were all high ACE years as well. So there's upward motion down here attracts the trough, and you just get the jet to crash in there. But if the trough is far enough east, it forces the jet over, and it bulges right here, and then you cap the upward motion to the south, and then things really get going, and you get tracks coming into the United States all the time, like we had in 2005 and 2004, and years similar to that. Now, the question is whether this can be extrapolated. This is during August to October. Can this be extrapolated to the period we're in now, late winter and early spring? And if we do this, look at February to March. Here are the years where there were few landfalls, but high ACE years. Notice the negative PDO tends to form a ridge in the North Pacific. Most of these years, by the way, have a negative PDO. That's why this trough is here in most of these years. Almost all of the active years and the landfall years all have negative PDOs. So the condition for this is that if we have a negative PDO, we can look for this. The ridge is over here in the North Pacific. Notice it's back by the Aleutians in years in the springs preceding years with few landfalls. But in the years with landfalls, notice this ridge extends its nose much stronger to the east and towards the west coast of North America, and we have a much more pronounced trough in western Canada as a result. I think this reflects the strength of the negative PDO pattern in terms of how far to the east it can push this pattern towards the coast of North America. If the ridge is wimpy and back here in the Aleutians not extending much to the west, that translates to the summer pattern where this trough does not get pushed far enough to the east and it results in a trough here that recurves everything. If, however, the ridge is strong in the spring, it translates to the summer in that the trough pushes closer to the west coast of the United States and forces the ridge over here and brings the storms in. So it's related to the strength of the negative PDO pattern, I believe, in what I have seen and what I have studied. And this is something we could possibly draw on, and we'll have to see how well that works. This year so far, since February through mid-March, we have a strong nosing ridge towards the west coast, which at first glance seems that, based on that hint, would favor above normal landfalls this year. However, the forecast for the next 2 to 4 weeks from the GFS and the CFS indicates this ridge becoming a little bit weaker and farther back to the west here with this trough offshore. So we'll have to see. We have to wait for persistence probably through May because this correlation does occur from March through May. So if we see this ridge, we'll have to see how the PDO pattern develops to better gauge how strongly we might get ridging over here during the summer. But it's fairly hard to predict, is rather uncertain, and we still have several months to watch this pattern develop. Predicting landfalls is no certain thing, but I do believe that there is a slightly above normal risk to the eastern seaboard this year, given that the analogs we have show the pattern that we get storms coming out of the deep tropics. They're not up here where they recurve right away. They come out of the south, which means they have a chance to recurve into the land before they leave. And similar to the last couple of years where we had Irene in 2011, Sandy in 2012, obviously, that kind of a pattern persists, I think, and the East Coast is at risk, along with the Northeast Caribbean, where storms can come out with those tropical waves. And as for the rest of this region here, the Western Caribbean and the Gulf of Mexico, it really depends. If the pattern nudges enough to the west where Florida and the Bahamas are threatened by these storms, then this whole area tends to light up in years like that. And then the entire United States and Caribbean coastlines are at risk and we have a high landfall year. However, if like 2010, 11, and 12, all of the storms tend to recurve just off the eastern United States or into the eastern United States, then we end up with a dry zone to the southwest of those tracks for Florida, the Gulf Coast, and the Western Caribbean, and then we only focus activity in the monsoon, the Eastern Pacific monsoon, where the Western Caribbean, far Western Caribbean, and the Southwest Gulf of Mexico that get the action, a dry zone in between, and then the rest of the tracks out to sea over here. That's what usually happens. So it'll depend a little bit on where these storms tend to go during the midpoint of the season, and we will of course talk more about that as time goes along and the pattern evolves. So overall, my thoughts for this year are an above normal season, 14 to 16 named storms, probably 8 to 10 of those hurricanes, 3 to 5 major. We could have about 2 to 3 hurricane landfalls on U.S. soil this year. The average is about 1.5 per year since 1950. That's the long-term average. We're still in the middle of a major hurricane landfall drought in the U.S. We haven't had a major hurricane landfall since Wilma in 2005. As far as I'm aware, that's the longest running streak in known history. Hopefully that streak continues this year. But as the negative PDO continues to develop as it has since 2007, coupled with the positive AMO, it's only a matter of time before those landfalls come back, because like the 1950s, this multi-decadal pattern tends to favor highly active Atlantic seasons that end up spraying their tracks towards land because of the pattern that these two oceans give to North America. So that's something we're going to have to be watching carefully because these years can easily turn into bad ones. And as always, please be prepared, please be safe. Any year can send a storm your way, so please be ready for this year as well. And that's it for now. Thanks for watching.